Hi everyone, so by now we should have covered similarity, and we know that similar triangles have the same angles as well as proportional sides, so we can match the sides and cross multiply. So one of the progressions we've done in my class, I like to take it from a circle and we cut it in half, and we studied that half a circle makes 180. Even if you cut it in multiple spots, it still adds up to 180. And like a linear pair, these two angles would add up to 180. Even if you cut it into three angles, A, B, and C make 180. All right, the next thing we did is we cut it in half again, and we learned about perpendicular lines and right angles, and began to understand, perpendicular bisector. And now we're at the next progression. So if we cut that line in half one more time, the angle, we go from 90 to here, halfway through. So that would end up giving us what we call a 45, 45, 90 triangles. And we begin to understand that the coordinates of these right triangles, every degree, 1 degree, 2 degree, 3 degree of a right triangle, is simply just one little degree around the unit circle. So we can use this circle and go to each degree and make a triangle. And the first triangle we tend to study is the halfway point. Both sides will end up equal, and that's why it's going to be isosceles. That will end up giving us two angles that are congruent, and it'll give us two sides that are always congruent. And then incidentally, when we get into understanding sine and cosine waves, the waves come from the coordinates all the way around the circle, and when you plot those coordinates on a graph, it makes waves. So the 45, 45, 90 triangle will give you a right angle. That's where the 90 comes from. And because these two sides are equal here and here, it will make the two angles congruent as well. Now, since they're congruent and they have to add up to 90, because 90 plus 90 makes 180, every triangle needs to be 180, we know then that if this is 90, that these two are 45 and 45. Now, oftentimes they won't tell you that. They'll just give you the shape with the angles marked, hope that you notice, or give you the shape with the sides marked and expect you to notice. So the way we solve this using similarity is we're going to use a reference triangle, because if we use the Pythagorean theorem, we can find a pattern of how these sides compare to each other. So we'll call this side 1, and because they're congruent, both sides are marked congruent, it's isosceles, we know that this would be 1. So if I were to take the Pythagorean theorem, I can find this missing side, call it C, the hypotenuse. So 1 plus 1 is 2, and so C squared is 2, and to get that hypotenuse, we square root to get C alone. C would be radical 2. So no matter what the sides are, we're going to keep getting this pattern, 1, 1, radical 2. And if the triangle is a 45, 45, 90, it'll always have that pattern, whether it's big or small, because they're similar. By angle, all triangles that have 45, 45 will be similar. So I'm going to take this idea of this triangle and the sides being 1, 1, radical 2, and we're going to use that to solve basic and a little bit more complicated versions of 45, 45, 90 triangles. So let's begin. The 45, 45, 90 triangle, let me see if that picture will paste. So as we learn and see it more and more, we start to see the pattern. 8, 8, well, those are the same because they're isosceles. And this ends up 8 radical 2. 11, 11, 11 radical 2. So we can do this by solving as well, but sometimes that pattern won't work so easily. So it's also good practice to practice similarity problems. So let's do one like we just did. We'll call the side 8. We'll put that as x. And we're just going to use our reference triangle. We're always just going to pull this up in our brain or on our notes if we're allowed to use our notes, and have the same numbers will always work. 1, 1, radical 2. Those are the patterns of all of the similar triangles that are 45, 45, 90. They will always have that pattern. So we're going to match the sides. 8 is the side, which would go where 1 is. 8 goes with 1. And we're going to set it equal to the hypotenuse x goes with the hypotenuse radical 2. So what I did there is I matched. This side goes with this side. They're in the same position. And this one, x is in the hypotenuse spot, which matches with the other one, square root of 2. Oftentimes I've seen students do this. They'll just put it radical 2 and 1, and then cross multiply. So a lot of times I see them just put it in the picture. They set it up on the picture. You could do that. So now we're going to cross multiply. X times 1 is 1, x, and 8 times radical 2 is 8 radical 2. So x is by itself. That's what we wanted. That's our answer, and it follows our pattern, 8, 8, 8 radical 2. So let's see when it doesn't come out so nicely with the pattern, how to do the same types of style where we're using a reference triangle. So what we did is we set up our reference using our reference triangle. Then we cross multiply, and then we'll have to rationalize sometimes the denominator. So if the square root ends up on the bottom of a fraction, we have to do what's called rationalizing the denominator, and there's another video, maybe I'll link it to this one. So let's try one that's not as basic. So one thing you could do is when I put it up there, you can pause it and you can see if you got it right. So what about when this is a whole number? The pattern won't work the same way. And some people can do it. I mean, you could still use the pattern and just multiply by square root of 2 in certain ways, but this particular way of doing it is focusing on the reference triangle, which I want my students to know, because that's how we do the 30, 60, 90. So I'm going to draw my little reference, 1, 1, radical 2. Remember, the hypotenuse is the radical 2. That's like 1.4, I think, if you put it in a calculator. The hypotenuse is always the biggest side. It's across from the right angle, the biggest angle. So we could put it like some students do, is, oops, I'll use green. They'll say 1, radical 2, and they'll cross multiply. Okay, I prefer, for notes especially, to make it more clear. I match the hypotenuse is the radical 2 spot. The leg is the 1 spot. There's 2 legs that are equal. So x radical 2 equals 10. For students who get stuck here, oh no, I see a radical 2. Think of it as the same as 2x equals 10. What would you do? 2 times x would make us do the opposite and divide. It's going to work the same way. So I'm going to divide by square root of 2. It works in the same rules. So this cancels that out. I now have x equals 10 over radical 2. So for those who already know how to rationalize the denominator, otherwise you might need to watch a video, we're going to get rid of this fraction or the square root on the bottom of the fraction, square root of 2, and repeat, multiply it on the top and the bottom, repeat. We multiply going straight forward. When you multiply fractions, you multiply straight forward. Sometimes people cross multiply. That's only when there's an equal sign in between them. So that ends up with 10 radical 2 over normal 2. Okay, and some of you might reduce that to 5 radical 2. 10 divided by 2 gives you 5. And we could try one more. So this one might be a little bit more challenging because we're going to have a little bit more to do with the radicals. Again, we're always going to use a reference. So in this problem, we know it's 45, 45, 90 because the angles are congruent. So we know the two sides are the same. You're going to notice that if you put a 5 radical 2 here, because they're the same, we can do the Pythagorean Theorem. That's going to be another video. Maybe I'll post a link here too. 1, 1, radical 2. So we're going to match. The side goes with 1, the hypotenuse goes with radical 2. So 5 radical 2 over 1 equals x over radical 2. When we cross multiply, x times 1 becomes x, or 1x. 5 radical 2 times radical 2. So in my class, I hope we've now learned how to multiply. Radicals go with radicals, whole numbers with whole numbers. Technically there's a 1 here. 5 times 1 is 5. Radical 2 times radical 2 is radical 4, but I always skip that step because we should know by now it's normal 2. Radical 4, or square root of 2 times square root of 2, remember, becomes something we could put under the same umbrella. So we take it out of the square root sign. Circle the pair, take it out. So 5 times 2 would be 10. So don't forget, there's videos on multiplying square roots if you need help. So this is how to do a 45, 45, 90 triangle using the reference triangle. And so we're making a similarity problem. So there's another video if you want to learn to do it with the Pythagorean Theorem. Then you just need to be careful, you know how to square square roots. Like how do you take 5 square root of 2 squared? And the other important thing is, like, can you know that x squared plus x squared equals 2x squared? So I'll be sure to put those in the other video.